As promised, I'm going to spend a couple of moments talking about these two equations. You will need them for solving the problems that I'm about to send out. You can consult your textbook, and of course, you can ask me if you have any questions. These two formulas look almost identical, but their meanings are nearly opposite to each other. So I'll start with the formula on the left. Think about a situation where waves pass through two or more openings or slits. Remember what I've said about waves, that waves spread out. So if waves emerge from one opening and waves emerge from a second opening, those spreading out waves can actually encounter each other. And if peaks passing through one opening meet up with peaks passing through other openings, you can actually get a reinforcement or a strengthening of the waves. That reinforcement is called constructive interference. And I'm primarily going to worry about light when we're dealing with these equations. So if you have constructive interference with light, it results in bright spots. You'll find other locations where peaks from one opening cancel valleys or troughs that passed through other openings, and in such cases you get an extinction of light or darkness. But this formula on the left gives you angles at which you find bright spots or constructive reinforcement. Well, I hadn't really spoken with you in a long time, so you might be familiar with that symbol from our readings, but I've never actually said it out loud to you. That's the Greek letter lambda, and it's our symbol for wavelength. So this formula reads n lambda equals d sine theta. N is any integer. I'll remind you that integers include 0, the positive whole numbers, and their negatives. So 0, plus or minus 1, plus or minus 2, etc. And if n is an integer in this formula, you can solve for theta and find an angle at which you find constructive interference or bright spots. The formula is valid for two or more slits. We will come back to the possibility of there being 3 or 4 or many such slits. Formula on the right looks almost the same. In the formula on the left, D was the separation between one slit and the next one. The formula on the right applies in the case of waves passing through a single opening, and the A in this formula stands for the width of that opening. This formula reads n lambda equals a sine theta. But in the case of this formula, the theta will actually be angles at which you find dark spots. And this darkness occurs because waves which pass through different parts of a single opening can sometimes cancel each other out. In this formula, n is any integer other than 0, because when waves pass through a single opening, you're going to find that the brightest spot is actually in the center, where theta equals 0. Keep these two formulas in mind. If we have, in this simplified course, waves which pass through two or more openings, we'll only be asking about bright spots. In this class, if I talk about waves passing through a single opening, I will only be interested in the location of the dark spots. There's one last little thing you need to know here. Over on the right side of the board, I've written an equation regarding the geometry of these problems. And I'll ask you to look at the textbook. They might use different variables here. But see if you can't make sense of this formula in terms of the questions you get when you receive those questions. And as always, you can contact me if you need any help.